Alright, so this first recording will show our first attempt on the programs that we ran on the servos. So for this attempt, you will see how the robot arm struggles to get into position. It shakes, it violently shakes, and you see as the voltage drops from 5 volts to 3 volts. We later on found out that there was something in the code that there was a kink in the code that we had to fix that was causing all the shaking and the voltage drop. Alright, so the next attempt is a couple videos where it shows that we try to get the robot arm to get into position to write on the board. We changed the code a couple times, trying to get it to angle right, just to draw a straight line on the board. We also cut down the delay time, trying to make an attempt where instead of waiting 6 seconds every single time it goes down to draw a straight line on the board, we wanted to cut the delay time to like 1 second, which you will see on the next video or next attempt. Alright, so for our final attempt, this code was more successful in getting the robot arm to draw on the board. We were trying to go for more of a triangle, but then for some reason, because the robot arm kinda is flimsy, is weak, and it can't draw precise points, it was able to draw like a triangle, like staircases with a square on top. But you will see on this video what it draws. Alright. Alright, so for this specific robot arm design, it is very flimsy, and because the robot arm is pretty weak, it doesn't allow like precise drawings. And we struggled a lot trying to get it to draw like circles or whatever because it's not strong enough to make that loop around. We've decided to buy another robot arm that will allow us to do like right draw and do like more with it because it will be stronger than this robot arm. This is our second robot arm design, and as we go on, it's actually because it's our third, we are learning a lot on how to improve our design. Alright, so now I'm going to demonstrate the Pi camera and how we program it so that it can take images. For this video, you will see that I take an image of a triangle that I drew myself. Right, first, right now I'm showing the code that I used. At the end of the video, I will upload the actual code because I realized that you can't see the code on the screen. I was recording this and typing at the same time, so please be patient with me. Alright, and here I am running the code, and you'll see the camera pops up on the screen, and I'm just trying to get it together while holding the camera. I'll take a picture of a drawing that I drew. Right. And so just so to show that we can set a timer, so let's say with the robot arm draws a picture, we can set a specific timer that then snaps a picture after a certain amount of time, so that way we can then upload the image, and then also being able to compare the image that was taken with the image that is uploaded to direct the robot arm to draw. And that's our code. All right, next I will show the communication between the Pi and Arduino communication. All right. For this video also, I will upload the code at the end of the video. And so that's our Arduino board, our Arduino Uno board, and then that's the USB connection that we made with the boards. This was really hard to record. Sorry again. And for this communication, pretty much we're trying to, if not a backup, to upload the image onto the Arduino board and then have it communicate with another software where it can compare the images. As of right now, we haven't figured out how we're going to get the images to be compared, but we have been looking at other softwares that can do that for us. And also the purpose of the Arduino and Raspberry Pi connection is to make sure that we can send like coordinate points. Let's say we upload the image onto the Arduino, which will be easier. Can send like we can load up the coordinate points where we want the robot arm to draw, and also so that the Raspberry Pi can compare. If we were to compare the image onto the Raspberry Pi, that makes sense. And once that code is ran, we see that the communication is just literally typing up hello from Arduino. So we see the communication. We're also able to do it with the rate values and points and things like that. Just didn't get to record it. And then I'm showing the code on screen. I didn't realize that you wouldn't be able to see it through the camera, but again, it's uploaded separately at the end of this video. All right, so for PCB, I have been struggling. We have been struggling to get the PCB here. Our first design, which was made early May, we had to go back and edit it by the end of May because we saw that we didn't need certain parts that were on the board. So we went back and edited. Even though we first ordered it, we had to cancel the order, just and then redo the order. For our second order, it's been taking forever. Finally, I was able to hear back from the company, and I had to go back and edit the board because our drill holes were too small. But I was able to accidentally order a couple parts that are all the parts that are on the PCB by accident from the company New York. So therefore, like, we're going to be able to design our PCB onto the breadboard because as of right now, we have been using a breadboard to connect our servos and to our Arduino board. All right.